Okay, today we will discuss some problem based on the rotatory motion. The question number 1, the question is given like a disc having radius 2 meter is placed on a smooth horizontal surface. Velocity of point A and B is given as shown in the diagram. Distance between the point O and the axis of rotation at that particular instant of time. This we have to find. So, our 4 options are: option number 1 is 1 meter, option number 2 is 0.5 meter, option number 3 is 0.25 meter, and the option number 4 is 2 meter. Now, see how to solve this problem. In the question, our disc is given. So, this is the disc, and this disc is kept on a smooth horizontal surface, and there are 2 points here, A and B. The point A is the topmost point, which is here, and this point have velocity here. Let velocity of point A is given here 4 meter per second, and point B is the lowest most point or point of contact. It has velocity 3/2 meter per second, and O is the center of a disc. So, we have to find the location of the instantaneous axis of rotation point from the center of a disc O. Okay. So, as per the determination, or as per the you can say method, we can determine the instantaneous axis of rotation like this: to join the point A and B whose velocity are given with a straight line like this, and velocity vector of A is your VA, velocity of vector B is your VB, and the length of arrow represent the 4 meter per second. So, this length represent 4, this represent 3/2. So, if that head of these arrow we are connecting like this, so this point, let this point your O dash called as a instantaneous axis of rotation. So, see from these two triangle, so from triangle, let this is your O dash A, and this point we can say A dash, this point we can say B dash. From triangle O dash A dash and triangle O dash B dash, these two triangles are similar triangle. So, triangle this and this are similar triangle. So, from similar triangle we can say A dash by A dash by B dash equal to here O dash A by O dash A by O dash B. Let we have to find some values. So, A dash is nothing your 4, and B dash is your 3/2 here, 3/2, and O dash A by, so from here we can say O dash A by O dash B is 8/3, and distance O A dash and O dash B is equal to 2 times radius. So, O dash A plus O dash B is your 2 into R, and R is the radius of the disc, which is given 2 meter. So, O dash A plus O dash B is your 4. So these are the two equation. Let this is equation number 1, equation number 2. Now we can substitute the value C. Suppose we want to find O dash A. O dash A plus, we can write here from equation 1 and 2. O dash A, O dash B can be written as 3 by 8 O dash A, which is your 4. O dash A is your 4 into 8 by 11. This is your O dash A, but we want O dash O. So O dash O is equal to O dash A minus OA minus AO. O dash A is your 32 by 11 minus AO, which is equal to radius of the this is your 2. So 32 minus 22, 10 by 11. So O dash O is your answer, 10 by 11 meter. The position of, so O dash A, this is approximately, so O dash O is approximately 1 meter. So our correct option is your option number 1. Option number 1 is the correct option. Question number 2. The question is this: a particle of mass m is moving in a horizontal circle of radius r with a uniform speed v. When it moves from one point to diametrically opposite point, its, so there are 4 options. Option number 1 is kinetic energy changes by mv square by 4. Momentum does not change. Momentum changes by 2 mv and kinetic energy changes by mv square. See the correct answer. So as per the question here, it is given a particle of mass m moving in a horizontal circle with velocity v. Let this is the velocity v. So when particle is reaching to the diametrically opposite point, let from A it start and diametrically opposite point is B. So here particle have velocity or downward direction or in this manner. The first thing, since it is given the speed of particle or constant, so kinetic energy does not depend on the direction, it depends only on the speed. If speed constant, so kinetic energy remain your constant. So first option is not correct. Second, momentum. So if we are talking about the momentum, momentum is a vector quantity. Initial direction of motion is this. Now direction of motion is this. So as direction changes, even the speed your constant, then also momentum will change because it is a vector quantity. The second option is not correct. Now third option, change of the momentum. So change in momentum, change of momentum, delta P is P final minus P initial. P final, final in that side, so I can write here mv minus, now since initial in that side, final I took the positive, this direction I am taking positive, so this will be opposite direction taken as negative. So change in momentum is your 2 mv. So this is the correct option. So third option is the correct option. So hence answer is your third. This is third option. Question number 3. The question is given as the moment of inertia of a uniform rod about an axis passing through its center of the mass and making an angle of 30 degree with the rod is, if m is the mass of rod, L is the length of rod, is given as first option ml square by 12, second option ml square by 16, third option ml square by 48, and fourth option none of these. Now see how to solve. As per the question here, let this is the rod and this rod have total length here L. Now they are talking about the axis. Axis make an angle 30 degree with the rod and passing from the center of rod. This is the left center of rod O, and axis is your like this, and this axis here makes an angle 30 degree with the rod. It means every particle of the rod is rotating about this, so we will find a let certain distance here. Let this is the y. So we can say that this particle is moving or rotating about this axis of radius r. Okay. So we will find moment of inertia. Di is, as we know, dm into r square. Dm is the mass of this part. Total mass is your m, the m by L, and this is your dy, and r is this, the r square. This is your di. Now we will calculate the value of y and r. See, in this triangle, this angle your 90 degree, this is your y, r is your y cos, y sin 30. R is y sin 30. So this is your y by 2. The substitute here r value. So dl is your m by L. R square means y square by 4 into dy. Now we will integrate m by 4L y square dy. Integrate from upper part to lower part. The lower part have limit L by 2, upper part have limit plus L by 2. Now y square integration y cube by 3. So this is your m by 12L y cube, L by 2 cube minus of minus L by 2 cube. So this will be your L cube by 4, L cube by 8 plus L cube by 8. So 2L cube by 8, L cube by 4. So ml cube by 48L. So finally this is your ml square by 48, and our correct option is your option number 3. So option number 3 is the correct option. Question number 4. The question is given as a particle of mass m attached to the end of a string of length L is released from the initial position A as shown in the figure. The particle moves in a vertical circular path about O. When it is vertically below O, the string makes contact with nail N placed directly below O at a distance h and rotate around it. If the particle just complete the vertical circle about N, then first option is h is equal to 3L by 5. Second option, h is equal to 2L by 5. Third option, h is equal to L by 5. Fourth option, h is equal to 4L by 5. See, as per the given question here, diagram is like this. This is the point O, about which our pendulum can rotate or our bob can rotate. Initially the bob is at a distance here or making an angle here 60 degree with the vertical. Now it has been released. It is given at h height below a nail is given. Let n for a nail. So as soon as this is coming here like this, as soon as your bob will be here, so the thread of the bob or pendulum hit at the nail, and then its motion is your circular about nail like this. So they are asking what is the h, so that it can just complete the circle. So see, the total length of string is given L. So this is your L minus h. As we know, when the ball has to make a complete cycle, so minimum velocity at the lowest point should be root over 5 gr, or the radius of that circle. So let velocity at this point your v, which is 0 because it has been released from rest. When it is reaching here u and it is completing a cycle, so the u, minimum value of u must be equal to root over 5g, or radius of that is your L minus h, then only it can able to complete. Now we can apply work energy theorem from here to here, or loss of potential energy. This is also L, it is given. So now we can say it has fallen this much distance. This is your L, this is your L cos 60. So loss of gravitational potential energy is equal to gain in kinetic energy. So loss of gravitational potential energy mgl 1 minus cos 60 equal to half m and u minimum square. See here, cos 60 1 by 2, mgl into 1 by 2, 1 by 2 cancel, l cancel. So gl is equal to your u minimum, that is this much. So 5g L minus h, L and L again cancel, g and g cancel. So L is equal to your 5L minus 5h. So 5h is equal to 4L. So that gives h is equal to your 4L by 5. So h is equal to 4L by 5. So our correct option is your option number 4. So hence answer 4 is the correct answer. Question number 5 is, a force F acts horizontally at the highest point of a solid sphere of mass m, kept on a rough horizontal plane. If the sphere rolls without slipping, find the acceleration of center of the sphere. The option 1 is given 5F by 7m, option 2 7F by 5m, option 3 7F by 10m, option 4 10F by 7M. Now see how to do. So it is given that this is your sphere of mass M, radius R, and this kept on a rough surface. This is your rough surface. And now a highest point, a force F is given. So you have to find acceleration of center of mass if sphere start with a rolling. See, first, without considering effect of acceleration, effect of friction, first we will find the how much the acceleration and in which direction of the point of contact. See, this exercise we are doing only for determining the direction of friction. So first, for translational motion, we can write A is equal to your F by M. And now if we are considering rotation about point O, for rotation about point O, Fr is I alpha, I mr square into alpha. So from here we can see A tangential your R alpha, 1 R are cancelled, that is your 5 F by 2M. This is your let second. So if we are not considering the effect of friction, so what we found, this have alpha this and this is your A. So point of contact, if we are considering, the point of contact have tangential acceleration this and translational acceleration in this side. So see, A is coming here F by M, A tangential comes here 5 F by 2M. So from here it has been found A tangential is your more than the A translational. So point of contact will have tendency to go backward side. That's why the now friction will act in the forward direction. So see, final FBD. If I am making here final FBD, to see the forces in final FBD, F is this, friction is your this. Now check it. Equation, translational acceleration AL, that will come from F plus F is equal to M into AL. AL means F plus F by M. First, now rotation. For rotation, F minus F into R, I alpha, I is here 2 by 5 mr square into alpha. So F minus F is equal to 2 by 5 m, 1 are cancelled, R alpha left, that is your A tangential. Second, now for rolling, A tangential is equal to your A translational, A tangential is your AL. A tangential here we can determine the value of A tangential. See, and AT is your AL, or we can add from here. On adding 1 and 2. When we are adding 1 and 2, so we will get 2F is equal to your MAL, and this is your 2 by 5 MAL, M plus 2 by 5M into AL. So AL is equal to 10F by 7M. So this is the answer of your question here. So correct option is your option number 4. So hence answer is your 4 is the correct option, 10F by 7M. Question number 6. Question is given as a rod of length L is pivoted at one of end and is made to rotate in a horizontal plane as shown in figure with a constant angular speed. A ball of mass M is suspended by a string of length L from the other end of the rod. If the angle made by the string with the vertical is theta, then the determine angular velocity omega. First option is your root over G by L 1 plus sin theta. Second option under root of G by L cos theta. Third option under root of G tan theta by L 1 plus sin theta. And the fourth option is your root over G cot theta by L 1 plus cot theta. Now see how to do this problem. First see the question here. This is the one we can say fixed support, and the rod is this. This is the rod, and this rod have length L, which rotates about this axis, we can say, with angular velocity or omega. And due to rotation of this from the other end, a pendulum is suspended, and that pendulum right now makes an angle theta. So this is the main point here. So what we will do, we will check the condition of equilibrium of this. See, for equilibrium of the bob, one force is your mg, another force your tension, and third force is the pseudo force, and this is the length L, so that will be your ml omega square. Now we can resolve. On resolving and applying condition for equilibrium, see, if we are resolving, T cos theta will be your mg, T sin theta will be your ml omega square. See, T cos theta is mg. So now for equilibrium of a bob, on resolving and applying condition for equilibrium, so this is the position of your bob, and the length of this string is also given your L. So this will be your L sin theta, and this is already L. So the distance or radius of rotation of the bob will be L plus L sin theta. So pseudo force will be your ml 1 plus sin theta into omega square. Now see the equation. T cos theta your mg, T sin theta is ml 1 plus sin theta into omega square. Now from these two equation, just divide this. Tan theta is equal to here L 1 plus sin theta omega square by g. So omega is equal to your root over g tan theta by L 1 plus sin theta. So finally our answer is your answer number 3. Now see the question number 7. Question is this: a spotlight is fixed 4 meters from the vertical wall and is rotating at a rate 1 radian per second. The spot moves horizontally on the wall. Find the speed of the spot on the wall when spotlight makes an angle 45 degree with the wall. So it is given as, according to the question, a spotlight is fixed 4 meters from the vertical wall and is rotating. See, let this be your vertical wall and a spotlight is fixed somewhere here and it rotates with angular velocity 1 radian per second, and the position of the spotlight is your 4 meters from the wall. Now the spot moves horizontally on the wall. Find the speed of the spot on the wall. So our first option is your 4 meters per second, second option is your 6 meters per second, third option is your 8 meters per second, fourth is your none of this. Now as spot moves, this is your, just see the vertical wall, and when the spot makes an angle 45 degree with the wall at this time. See, this is your 4 given here, so this is also your 4. So this distance will be your 4 root 2. Now the velocity of the spot v is equal to your r into omega, that we can say, or we can write one more point here. Let this is your x and this is your y. So as we know, x square plus y square, and let this here L square. So we have to find the value of dy by dt. X is your constant. This is 0 plus 2y dy by dt, which is equal to your 2L dl by dt. Now when we are looking the dl by dt at any moment here, this angle here, let us suppose theta, check it from here. This is your one equation. From another equation here, see, sin theta is your y by L, y is your L sin theta. This also we can write. X square plus y square is your L square is nothing, y square by sin square theta. Now x square is equal to your y square 1 by sin square theta minus 1. From here we can say y square is equal to your x square sin square theta by 1 minus sin square theta, and 1 minus sin square theta means cos square theta. Y square is your x square tan square theta, so y is equal to x tan theta. So dy by dt is your x sec square theta d theta by dt. So now x value right now, x is your 4 and sec square theta, theta right now your 45. So 1 by cos theta in your 2 and d theta by dt your omega which is your 1. So dy by dt will be 8 meter per second, and this is the answer number 3 which matches. So we can write answer number 3 is the correct option.